Record. I find what we're going to talk about today to be pretty interesting. I think it's relevant in the computer science world. So it's another one of these selected topics that I incorporate. Again, I've had students send me messages, or I've seen them after they've graduated and said, yeah, those extra topics did help. It gave me one of those days where I already knew what was going on and I was able to breathe for, and to catch up for a day. But so Boolean algebra is the algebra of the world of trues and falses. Okay. And we're going to take a look at a bunch of things going on with true and false and how we can use identities, just like in trig, you use identities, where you take a statement and replace it with something that's identical. We're going to use identities to help simplify these. And then one of our topics coming up later will be digital electronics, and you'll see how that ties into the Boolean algebra, and some things are be kind of computer nerdy will start to click and you'll be happy about it. So we're going to take a look at a couple of identities. Do we have to prove them? No. Could we prove them? Sure, we could prove them, and we're going to see that as we go through. But we need to start, first of all, by taking a look at, we have something that's plus, we have something that's a multiplication sign, we have a bar across the top, we have where operators are missing, and in our algebra world, we know that to be multiplication. We have something down here that's a circle plus. Okay, so the first thing I always need to do is, what is plus, what is multiply, what is circle? Plus stands for or. Multiplication stands for and this circle plus stands for exclusive or. Okay, how you remember them? Different students have told me different ways they remember these. Plus is a shorter word than times, or is a shorter word than and. I don't know. Different ways to remember it like that. Okay, so if I come back up to this first one, A plus B, this is the same as A or B is going to equal B or A. And in our algebra world, we know it's the commutative property. And this could be one of those where I could make it a 2-week course. And I had something like this when I was taking grad classes. And what you need to do then is say, okay, I need a truth table, and I'm going to look at the values for A and B, true, 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 false, false, true, false, false. And I start saying something, what is A plus B? And again, that's or, so that would be true, 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 false. And then if I reversed them, B plus A, I also get true, 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 false. Those two columns being equal means I just now proved the commutative property and I can use it. Okay, so whenever I have A plus B, if I want to switch it, make it B plus A, I can. And you can see where we could go through each one of these tediously and prove true and false. Well, the grad course I had then extended on this, where we proved all these properties, but we used them with like funky number systems. Like, what if I only had the numbers 1, 2, and 3, and so on and so on, different ways. But as you can see, we have some of the most common algebra identities: the commutative, associative, distributive. So if I did a truth table for any one of these, I would find out that the left side and right side columns would in fact equal. And again, we could sit here and draw this out where I'd have something much larger to work with, and we could go through and prove the distributive property does in fact work. The next two are kind of cool. Something called De Morgan's law. Okay, and one of the things we didn't talk about yet is that bar across the top, and that bar across the top stands for not. So if I have the not of the quantity A plus B, I can replace that with the not of A times the not of B. Now they're different because here I would do A plus B first, then not that column. So I would take all of this, and if I knotted that column, I would get false, 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 true. Okay. Over here, I'd take the knot of A first, I would take the knot of B first, and then multiply them, which is use the and statement on it. And the second to Morgan's law, the knot of A times B actually equals the knot of A plus the knot of B. If we had time, it'd be great to draw these truth tables. But once we start in about 10 minutes, what we're moving on with, you'll see that we're doing truth tables and we don't really need to go back and prove those. The next group, starting with number 10, that's the knot of A. So it reverses itself. Okay. I have zeros and ones. What does zero stand for? Well, in our computer world, we're all about 0 and 1. 0 is false, 1 is true. Okay, 1 is true. So if I took a look at that first fellow up there, that A plus 0, I'm thinking of A and values for A, true, false. I'm thinking of 0, which I know is false. So if I said A or 0, A ORed with 0, what would I get here? True or false is true, false or false is false. And guess what? That A plus 0 is actually the same as A. So we just proved the number 6 to be true. Anything ORed with 0 is going to be itself. Check this out. Anything ORed with true is going to be true. Anything ORed with true is going to be true. Okay, that makes sense. So here's a whole bunch of little ones that we'll be able to use as identities. So if I come across a situation where I have A plus 0 equals, I can change that to just A. All right, here's some more. Oh boy. 13, give me a 4-letter word.
Bake.
A 4-letter word for number 13. Don't say Mississippi. That's not 4 letters. It looks like I take first times first plus the outer 2 plus the inner 2 and the last. Give me a word.
Oh, you mean foil?
Foil, yeah. Foil is okay to use. I still like double distribute. We take the A times the C, the A times the D, the B times the C, the B times the D. Oh, check that puppy out. A times A plus B equals A. Ha! We're going to prove that one. We're going to prove that one. A times A plus B equals A. All right, let's see what we got. A times A plus B, A plus B, and we want to simplify that. All right, so if I remember right, I do in fact have the distributive property, correct? So this is also going to equal AA plus AB. All right, A times A, remember that's and if I actually have this, and you'll start to memorize these, what's another way of writing A times A? Just A, right? I hate when I answer my own questions. Somebody help me out. A times A, what is it?
Is A.
Just A, right? Okay, good. Well, if I can distribute, I can also factor. So again, this is the algebra of Boolean. If I factor, I pull out an A and I have 1 plus B. So I'm taking B and I'm ORing it with true. Well, oh, look at all that. There we go. Nice job, Harrison. What is B plus 1? Anything ORed with 1 is always going to be true. So now this is going to equal A times 1. And in our regular algebra world, it works the same as here. A to anything, or anything ANDed with 1 is itself. So this is going to end up equaling A. So this fella right here, A times A plus B equals A, does in fact actually equal A. So now I've just seen a way to create an identity. I created identity number 14. I created it by doing Boolean algebra. I just proved that identity by Boolean algebra. Another way to prove an identity was over here using a truth table. So I have two different ways to work with some of these. 15. 15 is the exclusive OR. What does exclusive OR stand for? Does anybody know?
One
It's
or
like
the other,
either
but
or.
not both.
Excellent. One or the other, but not both. Another way to write A exclusive OR B is A times B naught plus A naught times B. Because sometimes we don't want to work with exclusive OR, we want to go a different direction. Again, this is what we're learning today is a step that's going to learn into this thing called digital electronics that some of you have seen, and we're looking at ways to simplify some of those. All right, so I have a whole list of identities, rubbing my hands together. Again, these are located on D2L under the navigation bar that runs across the top under content. Ba-da-ba-ba-ba. Okay, so I'm looking at number 1. Simplify the following expression as much as possible. Oy vey. Let's see what we can do. I have A plus B plus B, A. I have a knot across the A. I have a knot across all of that, and I have a knot across the whole thing. All right, I wrote it on there. That way I can flip back to my identities page so that I can say, oh, I'm using identity number da-da-da-da to prove this. All right, anybody know where to get started? Well, I'm going to get started with that big knot and try to clean him up. And if I look at that big knot, I notice I have a left side plus a right side. So at this point, I'm going to say, I am going to use De Morgan's law, number 4, the knot of a sum. And what does that become? That becomes the knot of the first. And let's see, here's what the first was. The knot of the first times, here's the second, the knot of the second. What we got going now? Somebody throw a number out at me between 1 and 17.
Well, you have two knots over like one term, so those could just cancel out, right?
Yep, number 10. Number 10 says the knot of the knot. And now this left side becomes A times A plus B times, what do we have going on the right side? Looks to me like De Morgan's going to come into play again. The
Can you
knot
turn
of
that into not B times A?
it's going to become, you're really, really close. Tell me which De Morgans we're using. Number 5, right? On the identity sheet, the knot of a product becomes the knot of the first, so the knot of B plus the knot of the second, which is the knot of knot A. You lost your plus inside of there. And again, I'm writing this out step by step. Eventually, you'll start skipping some steps, but we get something that looks like that.
Professor, do you want the law next to when
Nope.
Prove, okay.
No, I'm just trying to point them out now so you see where they are. And again, the more of these you do, the quicker you'll get. You won't need to look at the identity sheet. I'm going to take this first one. I'm going to distribute A plus AB. And that's going to be times not B plus A. And wait a minute, I remember doing this, right? What's A times A? Anything ANDed with itself should be itself. If you're not sure, you can go like, here's A, true, false, false. And if I AND these together, right, I'm multiplying, which is the same as AND. What is true ANDed with true? It's true. False ANDed with false, it's false. So A times A really is the same as A. So this becomes A plus AB. I can pull the A out. I'm left with 1 plus B. Anything ORed with true is 1. It's always going to be true. And anything ANDed here is going to be itself. Distribute again. I now get AB naught plus AA. What is AA? We've already talked about AA. It's just A. Yay! I pull the A out. Anything plus 1, again, plus is ORed. Anything ORed with true is going to be true. Anything is A. Yay! So this big bad mama jama right here, if I drew all that out and did all those with truth tables, I'd end up with it being exactly the same as my column A with the trues and the falses. So I've simplified all of that work. Yeah, Harrison, you're right. And that's what I mentioned earlier. It's like trig identities. And again, you're using ones and zeros, trues and falses and all that. Yes, CJ, it's in discrete. Did you already have discrete? You can talk. You guys don't have to.
Yeah, I did.
Okay, so hopefully some of this you do in discrete and you're going, hey, yeah, why didn't I have one before the other kind of deal? All right, number two says, find all ordered pairs A, B that make the following true. So this time, instead of trying to simplify it, I'm going to try to find all the ordered pairs that make it true. All right, so my problem is A plus B, and that's knotted, plus A not B, and that whole thing knotted. Now, somebody's going to say, can we simplify this first if we'd like to? And my answer would in fact be yes, you could if you wanted to. But we know we want to find all the ordered pairs that make this true. So I'm going to draw a truth table, A and B. True, true, false, false, true, false, true, false.
It'd be all the ones where A is true.
Would you look at the answer already?
No, it's because that whole thing just simplifies to A. So B is like irrelevant here.
So you
So
simplified.
it'd be all the ones where A is true, wouldn't
So
it?
your answer would be true, true, and true, false.
Yep.
All right, let's see if we get that. I want to know, when is this guy going to be true? So the first thing I'm going to do is find out what A plus B is. That's my plan. Then I'm going to take that and knot it. So I'm going to take that column and knot it. Then I'm going to do A not B. Then I'm going to do A plus B naught, which is this column, plus A not B, which is that column. And then finally, I'm going to not this column right here. Let's see, column 4, I'll call it. I'm going to not column 4. Okay, plus. Plus is or and. So I want to or these. Or A's and B's. What do I get? I know you're all taking your own notes, but hopefully you got true, 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 and false. Anybody agree to that? Just say yes.
Yeah.
Okay. If I not that column that I just worked on, I get false, 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 true. Now I'm going to not whatever A is, and then I'm going to and it with B. So I'm going to not my A, which is a false, and I'm going to and it with true. That's a false. I'm going to not A and it. That's a false. I'm going to not A, which is now true, and it with B. Oh, that gives me a true. And I'm going to not A, and that gives me a false. Next step, I'm going to or columns 2 and columns 3. So I want to or this. False or false? False, false, true, true. Now I'm going to not that. I get true, true, false, and false. The question asks for what ordered pairs make this true, true, and true, false. So if A is true and B is true, this guy becomes true. If A is true and B is false, this guy becomes true. Cool. Number 3, simplify the following expression to one that uses only 2 operators. 2 operators. Let's see, I have parentheses, A plus B times C. I have a not over A, a not over B, a not over all of A and B, a not over C. Plus A times B plus C naught, and a not over the B plus C naught. Make sure I copied that right. Not over not A plus not B times not C plus A times the not of B plus C naught. I see a couple of you are going to town. I like it. I'm going to use De Morgan's on this plus. So it's going to become the not of the first, which is just A, times the not of the second, which just becomes B. Nice. I kind of like that. And yes, if I wanted, I could write this as A, B, C naught. This becomes A times the not of the first, which is not B, times the not of the second, which just gives me a C. And yes, I could write that as A, B naught, C. Oh, we're halfway there. Oh, we're living on a prayer. Now you know why I keep my day job. What did the fish, I know, what did the fish say when it hit a wall? Somebody has to know this. Huh, Nathan, what did the fish say when it hit a wall?
Nothing, because fish can't talk.
Yes, it said damn. Get it, damn.
Uh,
All right, never mind. Back to work. I'm going to pull out the A. I'm left with B, C naught plus B naught C. First times the naught of the second plus the naught of the first times the second. That looks kind of familiar. What is that? Is that in fact exclusive OR? Double checking. I'm looking at, nope, no two. Let's see, exclusive OR says, this becomes, and I'm looking at 15. This becomes the first times the naught of the second plus the naught of the first times the second. Yay. How many operators am I down to? Two. Exclusive OR, multiplication. Finito. I'm done. QED. That stands for something. Something you're supposed to write when you finish a proof or a problem. But I was able to simplify all of that down to two operators. The point is, look at all the operations I've saved in my world, that when we get into digital electronics and we're drawing, circuit boards and we got all this going on, and oh boy, we can simplify it. We save a whole lot. Harrison said, I thought they were both B, snot. Snot, snot. I like my answer. Okay, so oh, look at that, aren't you lucky? I have a collection of problems. Look at all those on the next page. We still have 18 minutes. I'm guessing you're going to say, hey, can we do problem number? What do you want to work on? The truth tables or simplifying, which sometimes can intermix. Any number, pick a number.
Let's do number 2.
All right, start with number 1. Why not start with number 1? It's logical. We're doing logic. Logically, you'd start with the first one. Maybe we'll have time to get. Find all ordered pairs such that AB times A plus B knotted has the same values as A exclusive OR B. Get this paper out of my way. So I'm going to do a truth table because I want to find ordered pairs, and I like doing truth tables. I usually just can't draw my lines very straight. And I know it's going to be true, true, false, false, true, false, true, false. What if I had 3 variables in here, like A, B, and C? A, B, C. How many combinations would there be? So
8.
8, right? If I had 4 variables, how many combinations would there be?
16.
Yep, 2 to the 4th power, 16. Keeps going up by a power. So here, instead of going by 2, I'm going to go by 4s. 1, 2, 3, 4, and then I'll go by 2s. And then I'll go by 1s. It's a nice organized way to get, yes, you're correct, Harrison. It is a nice organized way to get all of my combinations so I don't screw them up. And then I'd have 4 falses. I'd have 2 and 2 again. And then I'd have 1 and 1 again. So if there was another variable, I would do all trues here and then repeat that with all falses below it. All right, so let's see. I need AB. I can do that. I need A plus B. and then I'm going to not it. And then over here, I'm going to do exclusive or. Exclusive or, one or the other, but not both. I'll do that one for you. False, true, true, false. Yay, got that column done. Pluses or timeses and. I thought the more I write that down, the better off I am. What is this column? AB, what does it become?
True, false, false, false.
Thank you. True, false, false, false. A or B, what's that become?
True, 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 false.
True, 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 false. I left room in here so that I can now say what's the not of that. And I'm going to make this false, this false, this false, and this true. And the question says find all ordered pairs where this column is equal to this column. So it's when A and B are true. That's one. No, no, no. It looks like only when A and B are both true. Oh, better check my answers. And I messed up something on my answers. Let's double check this. This is true, false, 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 false. True, 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 false. Did I mess something up? A ended with B. True, 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 false, false, true, false, true, false, 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 false. A ORed with B is true, 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 false. When I negated that, I get false, 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 true. This is exclusive or one or the other, but not both. Huh. So it looks like on my answer sheet, I have 0, 0, 1, 1, but 0, 0 does not work. Only 1, 1.
I think you
Uh-oh.
hold on. Aren't we looking for A times B times the quantity A or not A plus B?
Oh, crap. We missed a step.
Yeah.
We missed this step right here. Thank you. Thank you. So I need this column 1, my bad, this column 2, and I need to multiply them together. Blah, 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 blah. So if I take these two columns now and I'm multiplying them, which is anded, what's this become? False, 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 and false. So now I have 2 matches. Phew. Good catch, Ryan. So my answer key was right. 1, 1. Again, when we talk about this, we can use ones or we can use ones and zeros, or we can use trues and false. Whew. It's not like I didn't have the column drawn to do it. Actually, I messed up on purpose to see who could catch it. You buying that? Jolie, do you buy that? Say yes. Hold the space. button.
Sure.
Sure. Nathan says no. Yeah, all right. What do we have? About 10 minutes. Let's do number 2 because somebody wanted to do number 2. Number 2 says, simplify the following expression to contain only operators not or exclusive or. I want to get it down to not or exclusive or. And my expression is A plus B. I have an exclusive or A, B, knotted. So I want to simplify that. And I'm telling you, can simplify down to not an exclusive or. Well, I think I'm going to have to bust this up to start. Exclusive or is the first times the not of the second plus the second times the knot of the first. First times the knot of the second plus the second times the knot of the first.
Reminds me of the product rule.
Yes. What is that? X dy plus what? How's that go? U dv, v du. It's been a while since I taught calc.
Pretty much the same, but instead of not, it's derivative.
All right, so I'm going to work on this side. A plus B times AB. And I'm going to make this now, I'm going to distribute through. I get AAB plus ABB. AA I know is just an A. BB is just a B. What is anything ORed with itself? What is AB plus AB? And again, those identity sheet is going to come into play until you get this down. But I believe this just becomes AB, correct? Frisnizzle. Questions on the left side. The right side, I'm going to use De Morgan's. Not A plus not B times not A, not B. The knot of a product is the sum of knots. The knot of a sum is the product of knots. Distribute A naught, B naught, plus A naught, B naught, B naught. That becomes A naught, B naught, plus A naught, B naught, which becomes A naught, B naught. I need to write this down. I know I'm going to use exclusive OR. That was the first times the knot of the second plus the knot of the first times the second. Because when I look back over here, it looks like this is going to turn into A because A matches A, exclusive OR, and these are opposites, so exclusive OR B naught. So it will become the first times the knot of the second plus the knot of the first times the second. I like it. I got it down to a knot and an exclusive OR. Sweet. I hope this is intriguing to some of you. You think this is kind of cool. I am going to stop there. We have 5 minutes left, but I don't think I want to start another one.